Hey guys, before the video starts, I just want to tell you that if any of you want to watch any of my content for free without ads, you can watch it without logging in if you follow the link down in the description. Hello everybody, my name is Bowden, and this is section 3.6, question number 10. The question reads, a pie is removed from an oven with a temperature of 400 degrees Fahrenheit. The room temperature is 78 degrees Fahrenheit. After 5 minutes, the temperature of the pie is 300 degrees Fahrenheit. Well, the first question asking us to do is write a function describing the temperature at the time t, where we need to have a k variable describing the rate of change. But first thing we're going to have to do is solve for k. Well, to start off, this function is going to be an exponential function, specifically the modified exponential function for the Newton's law of cooling. In this, a is equal to the temperature of the pie minus the room temperature, so 400 minus 78, or 322, where d is the temperature of the room, so just 78. Because we are solving for k, we're going to have to plug in an x value that we already know the output for, which is going to be 5 minutes, where the output is going to have to be 300 degrees Fahrenheit. Now, let's solve for k. The first thing we gotta do is subtract 78 from both sides, which is going to be 300 minus 78, or 222. Now we gotta divide both sides by 322, and we can rewrite this as 111 over 161. The next step is to take the natural log of both sides. Now let's take a look at some logarithmic properties. One of them is that the natural log of x is equal to the log base e of x. We also know that the log base b of b to the power of x is equal to just x. And so logically combining these two, we know that the natural log of e to the power of x is equal to just x. Where in this case, k times 5 is the x, so we can get rid of natural log of e and rewrite this as k times 5 is going to be equal to natural log of 111 over 161. Now we can just divide both sides by 5, but to keep our notation clean, I'm going to write this as 1 over 5 times the natural log of 111 over 161. And now that we have what we're looking for, k, we can just plug this number into the equation. And now we can replace the 5 and 300 with t and the function notation f of t, which is our answer for the first question. Now the answer to question B, which is what will the temperature be after 12 minutes, is going to be f of 12. And they want to round our answer to the nearest degree. So first of all, we got to take the function we have and plug in 12 as the number. And now after solving all of this using a calculator, we get approximately 209.9, which we are going to round to the nearest degree, so it's around 210, and that's going to be our answer. And after turning these answers in, we can get 1 out of 1 point because both of these questions are correct.